In this video, we're going to talk about how we can load data from external sources like files into R. So in most cases, when you're working with real data, you're going to load it from files. One example of the type of file you might encounter for storing tables of data is something called a CSV file, which stands for comma-separated values. Tables also often distributed in Excel spreadsheets. And then there's a lot of other formats like JSON, XML, and other types. Another data source you should know about is databases. Rather than unique files, these are typically programs that you interact with that store the data. So if you want to load a table of data from a CSV file, you can use a function like this one, read_CSV, that is part of the tidyverse. And it's pretty easy to use. All you have to do is put the name of the file as a character string as the first argument of the read_CSV function. There are other functions in R that will also load CSV files. R comes with a function called read.csv, but the tidyverse version is much easier to use and tends to give better results. The other nice thing about read_CSV is it returns a tibble rather than a data frame. Here's an example of how we could load data from an actual file. So I have a file on my computer called heartdisease.csv. So I supply that as the first argument to the read_CSV function and assign it to a variable called heart disease. That means when it loads the file and creates a tibble to hold this table of data, that tibble is going to be assigned to this variable. The read_CSV function typically gives you a bunch of information after you run it. In particular, it will tell you the types of data that it detected within each column. So here it's telling us that these three columns, diagnosis, sex, and location, were detected as having character data, CHR. On the other hand, DBL stands for double, which is how a lot of programming languages refer to numeric data. And what this line here is saying is that these other columns were detected as having numbers. So here we're using a function called glimpse to print out some of the information about this data frame. And what it shows us is the 16 columns that were loaded from the file, as well as the type of data that is being used to store each column. And then we see some of the values from the first few rows of each of those columns. There are similar functions to read_CSV for loading files, loading data from other types of files. So if you have data in an Excel spreadsheet, which would typically have the file extension .xlsx, then you could use a package like readxl, which contains a function called read_xl, to open that file, load the data from it, and assign the resulting table to a variable. Now, one complication here is that you do have to tell these functions whereabouts on your computer the data is stored. This is going to be relative to where R is currently running. Typically, when R is running, you'll see in the R console that it will list a folder on your computer. So if the data file is in that folder, then you can just put the name of the file inside the function. However, if it's not in that folder, then you're going to have to provide the path to that folder. So if you can give a path that's relative to the folder that R is currently working in, so let's say that within that folder you had a subfolder called data, and within the data folder was the data file. You could specify the subfolder followed by a slash to indicate a break between a folder and its child, and specify the full path that way. Alternatively, you can give what's called an absolute path, which is relative to the topmost folder on your computer. So on a Mac, for example, you would start with a slash, which would indicate the very topmost level, the topmost folder on your computer's hard drive, and then you would give a list of all the folders down to whatever the folder is that contains the file, followed by a file. Each one of these would be separated by a slash. On a Windows computer, you typically have to prefix this with the letter of the drive. So typically on Windows, most things are going to be in the C drive, so you would put C:, and then you would start the series of slashes and nested folders all the way down to the folder that contains your data, and then the file name. If you want to save data to a file, you can do so pretty easily. So if we want to save a table of data as a CSV file, for example, we could use the write_CSV function. The first argument here is going to be the tibble or data frame containing the data, and the second argument is going to be the name of the file that we want to create. So this first thing is going to be a variable. The second thing is going to be a character string. We can do a similar thing, for example, if we want to write our data to an Excel file, except here we would use the write_xlsx function. We mentioned before that databases are programs for storing data, typically as an alternative to just storing the data in files. The reason, or one of the reasons you might do this, is because then the database program can ensure that the data maintains the structure that you wish it to have. So for example, if you want a column of data to always contain character strings, a database can ensure that's the case. Whereas if you have a CSV file, then in theory, anyone could go in and edit that CSV file and put a number, for example, in a column that's supposed to only contain character strings. Databases are also useful if you have multiple tables of data that are related to each other. So you might have let's say you are running a website that sells things. You might have a table that stores all the information about your customers, and you might have another table that stores the information about the products that you sell. And then another table that lists all the sales that you've made, which references the people in the customers table, as well as the items in the table of things that you sell. And databases can help you maintain those and the connections between them. Databases are also useful if you have data sets that multiple people or multiple programs are working on at once, because they can ensure that nobody overwrites each other's work. You can even do data wrangling with databases. A lot of them will come with their own programming language, which will contain operations you can do to manipulate the data before extracting it from the database. If you want to work with a database in R, you can do so directly from R using a package like dbplayer. This is part of the tidyverse, and it allows you to use the data wrangling functions from packages like dplyr directly on the database, and means that you don't have to write any code yourself to manipulate the database. The R package will take care of that for you. And then you can treat the database much like a data frame that's already in R.